Hello everyone, today I'm gonna show you guys the simulation that I made in Godot to help um, my math subject, Information Mathematics number 3. It's a subject where we learn mathematics specifically for computer science related. Here is the question, the assignment. Number A, every particle inside a nuclear reactor splits into two particles in seconds. So every second, one particle splits into two. So there's two particles out there 1 second. Suppose one particle is injected into the reactor every second, beginning at t0. So at 0 seconds, the particle there's only one particle in the nuclear reactor. How many particles are there in the reactor at the end second? So let's just say every second the particle get inserted and the last particle that was inserted splits into two. I already found the formula. Here it is. T and the second of k minus 1, so before that time, times 2 plus 1. So let's just say in T1 it's 3p and T2 is 7p. How I found it, 1 times 2 plus 1, and then in T2 is 3 times 2, which is 6 plus 1, 7, and T3 it's 7 times 2, like 14 plus 1, 15, and so forth and so forth. And here I found the formula. T, like 1 second before the k, the second that is trying to be found, this is the formula, times 2 and then plus 1. Now I'm gonna simulate it here. Where it is? Okay, here it is. Now let me show you. So in time elapsed 0, it's 1, particle 7, 3, 15, 4, 31, 563, 127. Okay, my computer is crashing because it cannot comprehend this much particle, but it's basically the same as mine, like 3, 7, 15, 331. Let me show you again. 3, 7, 15, 31. Just like how I calculated it. 3, 7, 15, 31. So basically it's simulate just right. So basically my calculation is the same as the simulation calculation, the computer calculation, and the formula is just right. Now the second question is, when a particle splits into two, one of them is the original particle and the other one is a newly created particle. So there's two particles, the original and the newly created. Suppose a particle has a lifetime of 10 seconds. There's a particle created in the 0 second and will vanish after the 10th second. Repeat problem A and assume all injected particles are newly created. So after 10 seconds, the particle that was created on the 0th second will disappear. So the particle only have like lifetime of 10 seconds. So I made the function after it, like in here it is. Particle can decay. So I'll go here. Particle can decay equals true. So if it's true, if the time elapsed is 10, so after 10 seconds of the particle variable happening, it will queue free or it will exit the world. But the problem is this doesn't make anything because my computer is too weak. Look at this. 2, 3. It will never reach 10 because before reaching 10, there's too much particle for my computer to handle. Godot hasn't have like 3D batching yet, I think. Maybe it already have, but my computer is too weak. Okay, it's crashing right now. Look, FPS 1. My computer is crashing right now. Yep. 1023. Let's see on the 10. Let's see if my computer can handle it. I hope it can handle it. Okay, you know what? Let's not handle it. I don't want my computer to crash. I don't want my computer to crash. Okay. Since since my computer cannot simulate this question, my college assignment, how about we just do 5? How about if the the particle lifetime is only like 5 seconds for the sake of saving my computer from dying? 1, 2, 3, 4, 5. It's 63 now. 126, 255. So it used to be 255, but now it's 250. So 5. Let's just say now. Let's just say 2. Let's just say the particle only have 1 second of lifetime. 3, 4. Well, that was weird. Hmm. How about 10. That is not what I expected, to be honest. So on 0 it's 1, and 1 it's 3. Is it the same as my calculation? When 0 it's 1, when 1 it's 3? Yeah, it is. But why do I feel like it's not right? You know what, who cares? So basically, the simulation worked, but my computer is too weak to handle it. With particle can decay, without particle can decay, it will decay eventually. You know what? Let's make this easier for me. Particle lifetime. Um, export var particle underscore lifetime equals maybe like 5. Okay. Now if I save it here and I go here and I go here, I can say the particle lifetime myself. Let me try it. So after 5 seconds, it's gonna change for 563, 126, 250. Okay, my camera can handle it anymore. Let's change it to 3. Or maybe 2, maybe 2. My computer cannot handle this equation. 2, 8, 14, 20. Oh, it's different. Okay, so it turns out my computer itself cannot even help me solve the problem. So I will need the supercomputer. Maybe I'm gonna buy maybe some NVIDIA GPU so I can handle like 3D batching or something like that. So basically that's all I'm gonna show case today. Thanks for watching. You know what? I'm gonna show the code too. Here it is. Time elapsed. It will count how many times it happened in the world. Particle count. It will count how many particle exist in the world. It's gonna like load the particle scene. In the process, it will print how many times it has happened. Oh, you know what? Let's just comment it. I don't need anymore. And so in this code, it will like insert the particle underscore count variable into here. And time elapsed, it's gonna insert the time elapsed variable by the time underscore elapsed variable, which is like increased by every second by the timer node, which like call this variable every 1 second happen on the physics callback. Why? Because physics and idle is a different kind of callback. I think it has to do with delta. I will talk about it later. Particle underscore instance, it's basically instantiate this scene, add it as a child, and then set the global position as the marker 3D like in here. So it will spawn the particle here. Anyway, let's see the particle.gd script like this one. Like let me show you. This is a particle. Let me show you the code. This is time elapse. Particle can decay equals true. Particle underscore lifetime 5. Particle preload. So this is the time lapse after the variable like the particle show up. Particle can decay. This is set if the particle can like decay or not. Like does it has a lifetime? And this is how many lifetime does it has? Like is it like 5 second, 10 second? I made the export so I can like manually like let me show you. Here I can like manually change it outside the code. I've said like too many times. This is to load the scene. This is to like increase the second when it's first show up. Particle time underscore elapse. So it basically print the particle time. Yeah, I think I should like comment this. So every second, and it checks if the time elapsed is equals to the particle time, and if the particle can decay through, it will like queue free or like kill itself, like disappear from the scene. On timer timeout, like if the particle, like the timer, what if the 1 second like has happened when the timer reloaded to the scene, will increase time lapse by 1, and will instantiate another particle, basically splitting itself into 2 particle globe, and it set the global position into the marker 3D, basically just like this, this code. This is the UI. It only to show the code, like the data of the particle count, time elapse, and FPS. This set it every second. So that's all for the code review. This is just some documentation that I need because I don't know how to render some FPS. And that's all. And I'm gonna show you guys one more time, but this time with the actual lifetime. and I'm not gonna stop the simulation. I'm gonna let my computers suffer. Okay, just to simulate the second question. Let's do this. Let's do this. The second problem. 3, 15, 4. Can it reach 10? Okay, it's lowering. The FPS is lowering. It's going to 30. Okay, it's going to 10. 10 frame per second. 3 frame per second. It hasn't reached 10 yet. It's only 2. 2 time. Please, you can do this. Oh my god, my computer is dying. Oh my god, I'm sorry, Godot. I'm sorry, my computer. What have I done? 4, 1. Come on, one more, one more. 10. You can do this. You can do this. You can do this. My computer is dying. Oh, it's not responding. Oh no. Yep, my computer is dead. Can I? Well, life of a programmer, simulating some impossible stuff. Well.